Now that we know what it means to be continuous, or for a function to be continuous, there are some implications. If the functions f of x and g of x are continuous, then I know the following. The function f of x plus g of x is also continuous. So if I know both of these functions are continuous, I can tell you that the sum of both of those functions will be continuous. A constant times a continuous function is continuous. Just like the addition, the subtraction of one continuous function from another continuous function is continuous, so their difference is continuous. Their product is continuous. Their quotient is continuous at all points. Where the denominator, in this case g of x, is not equal to 0. And a function that is continuous that is raised to a power is continuous. So these are the basic combinations of functions that are continuous. A couple other things that are nice to know is that the composition of two continuous functions, if you remember, that's the symbol for composition of functions, performing them from right to left order. Another way you've seen this written is like this. This composition is continuous. And if a function is continuous, then its inverse function is continuous. On that interval, that function does have an inverse. This property right here, that the composition of two functions being continuous is continuous, will help you analyze various types of functions. We know that the sine function is continuous. So we know that sine of x is continuous because we know what its graph looks like. It starts out at 0, and then it goes up and down and up and down and up and down, continues on forever in both directions. So we know it's continuous. We also said earlier that a polynomial function is continuous. Well, the composition of these two functions that are continuous, for example, the sine of x squared plus 7, it also has to be continuous based on this rule. So if I have two functions that are continuous and compose them or combine them arithmetically in any one of these operations, they're going to be continuous when they meet these conditions. For example, there's that one extra condition on the quotient, that the denominator has to not equal 0 in order for it to be continuous. So again, as a reminder, if f and g are continuous, then their sums are continuous. A constant times a continuous function is continuous. The difference of continuous functions is continuous. The product is continuous. The quotient is continuous at all points where the denominator is not 0. A continuous function raised to a power is continuous. A composition of two continuous functions is continuous. And the inverse of a function is continuous where that function has an inverse.